Hello everyone, welcome to Anamacharya University. And myself, this is Karthik, Assistant Professor, Department of CSE. Today I am going to explain about the singly linked list. Now what are the operations we will implement in data structures using C programming. Now let's see second one. Before going to talk about the singly linked list, next what is linked list? Now a linked list is a linear data structure. Linear is nothing but the elements will be stored in sequential order, which can store a collection of nodes. In generally, collection of nodes together via links. That means here observe, this is the wait 1 second, right? This is a link. One link will be created. Okay, in singly linked list or linked list both are same. And this is the node representation. This is nothing but the data part, and this is nothing but the nest part. It will store the address of nest node. Now what is the definition? A linked list is a linear data structure which can store the collection of nodes. So this is the one node. It can store the collection of nodes means more than one. That means this is nothing but the data, and this is nothing but the nest, and second one also this is nothing but the data, and this can also it will store nest part. Okay, this is a completely linked list formation, right? A linked list nodes are not stored at contiguous memory location. Now contiguous memory location means the elements will not store adjacency memory location. Actually in arrays only the elements will store in contiguous memory location, but the linked list will not be stored in contiguous memory location. There is no adjacency nodes on one, right? In they are using linked list pointers to the different memory locations. That means each and every node having some address. Let us take example, and this node will store in 1000 memory location, and this one also it will store 2000 memory location, let us assume, and this one is also it will store 3000 memory location. Okay, the addresses will store in different memory location, right? That is the meaning of contiguous memory allocation, right? Contiguous memory location means not stored in adjacency nodes. That means, for example, if you take the node is the address is 1000, then immediately I want to store in second node in the 2000 address. Again third data or third node will store in 3000 address. Okay, right? This is completely our wish. I can save any node or any data part, it will store in any addresses. Okay, that is the in linked list, it will the elements will not store contiguous memory location, right? This is nothing but the linked list, and this is nothing but the linked list representation. Okay, that means a node consists of a data part and pointer part. Observe, this is a data part, it will store only data elements. This is nothing but the nest part, it will store only addresses of the nest node, addresses of the nest node. This is nothing but the node representation. Collection of nodes or collection of elements, we can call it as a singly linked list, or we can say linked list. Now let's see second one. Now this is a diagrammatic representation. Now before we are going to see what is that, this is the first node, or this is the second node, and this is the third node. First node we can call it as a head node, and the last node we can call it as a tail node. And this is the first part, first node actually, right? Then now let's see what is singly linked list. A singly linked list data structure is essentially series of connected elements where each element known as a node, where each element known as a node. Now one see, observe, okay, series of connected elements. Now here it is a node, okay, this is a single node, and one more node will be connected to the next node, right? This is one link will be formed. That's why this is a singly linked list. It has only one link. Okay, in this data part we will store the any elements. Okay, in this data part also I can store the element is, let us take 10. Okay, in the first node the having some address is 1000, the second node having some address is 2000. Okay, in the always nest part will store the address of nest node. That's why in 2000 will store to the nest part in the first node. Okay, the last node, let us take one more node, right? This is the node, and one more element, let us take 30. This node having some address, let us take 4000. right? And this is the node, it will store the address of 4000 because the node will store the address of next node. That's why it will store the next node address. The last one represents null. This is an indication of the list is or the singly linked list ended, right? The first node we can call it as a, this is the first node, we can call it as a head node, right? The last node we can call it as a tile node or null indication the list is empty or list is ended in that node only. Okay, now observe, this is the first node address, now this is the second node address, now this is the last one null. The first node having some address is 1000, 2000 and 4000, and the first node it will store the address of next node, and the last one it will store the address of next node. Now what about first address, how where the location the first address will store? In the first node content, it will store the address of is the head pointer. It will store the address of only first node. Okay, that is the first node address will store in head pointer. Here head node is different, head pointer is different. Head pointer will store the address of first node only. In the head node we can call the first node, we can call it as a head node, right? The last node we can call it as a tile node. This is the representation of singly linked list, right? Each and every node having some addresses, right? Okay, now let's see diagrammatic. Okay, now here it is same. In the node consists of data part as well as list part. The data part will store the actual data that the list is meant to hold. That means the data part will store only elements, not addresses. It can any type of data. Now here observe, it can store any type of data. That means if you want to store the numbers or characters or even more complex data structure also, it will store only data part only. Now same, in the node consists of also having next node. That means this is a pointer. Pointer is nothing but it will store only addresses, right? We can say pointer or reference node, right? To the next node in the list, it's how the list maintains its sequence by linking each node to the subsequent one. That means the link between two nodes. Okay, it has only forward directional. That means it has only single direction. That's why we can call it as singly linked list. Singly linked list. Okay, this is the diagrammatic representation of singly linked list. Okay, right? Next we will see first of all what is the node representation, how the node will be represented, right? See, this is a node representation. Now how we can represent a node with the help of structures. What is a structure? Structure, we can define a node. This is a node representation, right? With the help of struct keyword. In the structure, actually in the singly linked list having only two nodes. First one is data part and second one is next part, right? In the data part we'll store only data elements. In the next part we'll store the address of next node. That's why we can declare int and data. It means data will store. Right. Next, this is a self-referential structure because it has only one node. That too, itself only data will be stored. That's why we are using self-referential structure, and this is a pointer variable. Next is a pointer variable because it will store the address of next node. That's why this is a node structure. Now let's see. This is a simple diagrammatic node representation. Into data, it will store the data part, and struct to node star next. That means a pointer variable. It will store the address of next node, right? This is the next part. This is completely node representation, and this is the code. We have to write the node represent, right? This is the diagrammatic representation. Now let's see second one. Okay, now what are the operations we should perform in singly linked list? Now only we have to discuss in insertion at the begin, insertion at the end, insertion at the specific position. Now let's say first operation, insertion at the begin. Now what is insertion at the begin? We can also call it as a insertion at the head pointer, head or head node. Head node is nothing but the first node. In the first node we can insert any element or any node. Okay, this operation involves adding new node right at the starting of the list. That means we have to add the first node. In the first node we have to add the new node of the list, right? The new node then becomes head of the list, and this operation is quick because simply includes the points the new node to the current head of the list. That means it will store only head address, that means first node address, and then updating the head to this new node, making as constant time complexity. It has only constant time complexity, that's why this is the order of 1, that means constant time complexity. Observe, this is the algorithm, and also we have to write one function how the node will be inserted in the new node, right? First, what is the algorithm? Insertion at the begin. First of all, you have to allocate some memory for new node, and in the new node you have to store some data. Then what is the third one? Change the nest of new node to the point to head, and change head to the point of recently created node. Now let's see the function, all of you. First, this is a function name. Insert at begin is a function name. This is a parameter. What is the parameter? That what's our operation? First, I have to insert new node and new element. That's why one value will be passed as a parameter in the function, right? Then here it is a stuck to node star. This is a new node. One new node will be created, and I have to allocate some memory for new node. Okay, let us take one new node. Okay, this is a new node I want to insert at the begin. The new node address is, let us take 1000. Okay, this is the memory will be allocation. Okay, right. Before going to insert new node, first of all we have a list. Now let us take one example of singly linked list. Now this is a singly linked list. 1, 2, and this is 3. 1, 2, 3. Okay, each node having some address 1000, 2000, and 3000. Okay, in the first node it will store the address of next node, that is 2000. At that time one link will be created, that is forward link. Okay, yeah, that's why it has single link, right? In the second node it will store the address of next node, that's why this is a 3000. Okay, one link will be created. Now last one we can say null, because the list is empty. Okay, what's our operation? Insertion at the begin. Insertion at the begin. Here this is the place we have to insert. Okay, this will become, this is a new node, the name itself new node. Okay, and also printf enter a value. This is a user understandable statement. Okay, you want to, or if you want to take input from the user. Okay, user wants to enter the value. For example, I want to enter as a user, that is 10 or 10 will be inserted at the new node. Okay, that value 10 will be stored in this value. Okay, with the help of scanf function. Scanf means read a value. %d, you know already, %d is a form is specifier of integer. It will store only integer values. Okay, for example, now value is nothing but the 10 will be stored in the value. Okay, this is, observe the next line, new node arrow operator means we can access the value or we can access the address. If you want to access any value or any address using dot operator or using dot or arrow operator, these are the two operators are used in the C programming language. Okay, dot means nothing but the mode of using pointers. In singly linked list or linked list using only arrow operator. You can use dot operator also, but this is very simple. Okay, easy to understand. That's why you're using arrow operator. This is the arrow operator using only access elements, right? New node arrow data equals to value. This is the new node, this is the data part. Okay, this is the data part we know very well, and this is the address part, right? Okay, what is the value user wants to enter? 10 will be stored in the new node. 10 will be stored in the new node. Oh, again, new node of nest or new node arrow nest is equals to head. That means new node arrow nest. This is the nest part which store the address of nest node. Okay, we can write here the observe, this is the head node, and this is the tail node. Right, what is the head node address? 1000. Now here observe the statement, right? Head new node nest is equal to head and num. That means, right, new node of nest part, it will store the first node address, head node address. Now what is the head node address? 1000 will be stored. 1000 will be stored. Actually the new node address is 1000. Let us take 10,000 here, right? Now immediately what is the address? It will store the address of first node. Immediately the link will be created. One link will be created. Okay, this is completely. Finally what? New node will become head node. Now here it is a head node, right? This is completely insertion at the before. Right here observe before insertion what are the values or what are the nodes we have 1 2 3. This is the before insertion, before insertion, before insertion. Now after insertion one element will be added at the beginning, that's why now 10 1 2 3. This is after insertion. Okay, this is completely about the insertion at the begin only function, right? This is a function explanation. Now next we will see the insertion at the end. Okay, let's see the algorithm of insertion at the end. First of all, you have to allocate some memory for new node and store the value. Just you need to traverse. Traverse is nothing but the visit each and every node from first node to last node. Okay, now let's see the program first. Void insert add end. Void insert add end. That means this is a function name, right? Then you have to create one new node. This is a new node I have to take. New node, right? Then we have to allocate some memory, right? Let us take 1000, right? New node arrow data is equals to value. That means value will be inserted at the data part. Let us take 50. Then new node arrow next is equals to null. That means this is a null because what's our operation? Insertion at the end, because insertion at the tile position. Okay, before going to insert, now let us take one example list 1 and this is 2 and this is 3, right? Each and every node having some address 1000, or let us take 5000, 2000 or 3000, right? This is okay. First node will store the address of next node, 2000 will store in the link will be created, and the second node will store the address of next node, 3000 will be created, or the last one is null. Okay, before previously insertion the last one is null, after insertion one value will be changed. Okay, check here two cases will arise. Two cases. First of all, if the head is null, head double equals null. First of all, before checking the list is empty or not. If it is L, the new node will become head node. Okay, if it is not null, then you have to insert at the end. Okay, check. Now what is head? 5000. 5000 double equal, that means equal operator equals to null. Condition false. When this condition false, outside the blocks will be executed. Now what is outside the block? Start node start temp is equals to head. That means head node we will assume as a temporary node. Now let us assume this is a head node. Now we will assume as a temporary node or temporary point. Okay, now check the while loop. Until that condition false, the loop will be repeated. Temp arrow nest not equals to null. That means now what is a temp nest? Temp nest means this is the next part of temp. 2000 not equals to null. That means 2000 not equals to null. Condition is true. As 2000 not equals to true. 2000 not equals to null. Condition is true. Okay, the condition is true. Inside the block will be executed. Now what is inside the block? Temp arrow. Temp is equals to temp arrow nest. That means next node we have to visit. To visit next node. That means you have to traverse to the next node. Now here it is temporary node. Right, again check the while loop until that condition is false. Temp nest not equals to null. What is temp nest? 3000 not equals to null. Condition again true. Again condition is true. Inside the block will be executed. Now we have to traverse to the last node. Traverse means next node we have to visit. Right, again check the while loop. Temp nest not equals to null. That means what is the temp nest? Null not equals to null, but here equal to null. Condition is true. Condition is true. When condition is false. When this condition is false, outside the block will be executed, the loop will be terminated. Now finally we have to reach at the end of the position. That is our operation. Okay, insertion at the end. Right, finally new node. Temp of nest is equals to new node. Now what is the temp of nest? Actually previously null, but new node address, new node, right? This is a temp of nest, right? You have to store the new node address, that is 1000, right? Then immediately one link will be created node. Okay, this is finally insertion at the end. Okay, this is a we have to discuss only at the insertion at the begin, insertion at the end. Okay, thank you so much.